Let's get started. So first of all, just some really interesting facts about cloud native. So these come from S&P Global Market Intelligence. So 54% of mature public cloud users have platform as a service in place today. So just to phrase that a little bit, S&P Global MI and 451 Research, who they bought, who do all of this research, basically class you as mature if you are doing an element of platform as a service, not just infrastructure as a service. So class you as mature in the public cloud space. So 54% of the people that they surveyed, and it was over 3,000 organizations, said that they were doing platform as a service today, which is quite a lot, and for a lot of people I've spoken to, it's quite a shock as well. A lot of people expect that to be a lot lower. So again, 51% indicate that either all or most of their in-house built software is cloud native or cloud enabled. So just to explain the difference a little bit, we'll come on to cloud native in a second, but cloud enabled means that it has the ability to run in the cloud and execute without causing exceptions. And one of the other things that they noted in this research is that your traditional infrastructure as a service is in decline. So a couple of organizations ago, I worked for an airline, and this is very much true even from an airline's perspective, who they seem to be quite risk averse. And what's interesting there is that they were going from quite an infrastructure heavy platform all the way into the cloud, where there was very little or no infrastructure as a service in a lot of places. So lots of organizations across lots of different verticals, they're all moving towards these more cloud native platform focused services. So this is why it's really important as an IT pro to make sure that you are effectively prepared for the future and what that means to you. So at Ensono, where I work today, this is how we describe cloud native. So cloud native is when software development utilizes cloud to build and run scalable applications in modern dynamic environments. So we try to be quite careful with the wording, so it's not too ambiguous in a lot of areas. But the key thing really there is that we talk about the cloud. Obviously, it's very difficult to do a lot of the properties that come with cloud native without having a cloud environment. Even in a private cloud, it's quite difficult to get the same level of scalability and the same level of elasticity with a lot of your resources. So quite careful to use the word cloud to make sure that we frame it properly. And we also talk about it from a software development perspective, and that will come a bit more obvious as to why as we go through some of this. So what are the benefits of cloud native? There's several, but I pick out the important ones. So the first one really is that it's easier to manage. So these are all just in general as well, by the way. It's a lot easier to manage, okay? So previously, to be able to manage a service, you would generally have had the network, some storage, a virtual machine, the operating system, and then the application and the service on top of that. It's quite a lot, and generally in larger organizations, that's a number of different teams involved in managing that. If it's platform as a service, being able to do that function. So in Azure, for instance, we have Azure Function Apps or in AWS Lambda functions. They are serverless buckets of code that we use to execute very specific things. And that makes them very easy to manage because there's no operating system sitting under there that we have to manage. We are literally managing the code and the application on top of that. Lifecycle management is also something that's really important. Many people maybe don't know this depending on their role, but IT organizations and procurement departments within organizations spend tens of thousands of pounds and dollars and lots of effort making sure that support agreements are up to date, hardware is up to date, and making sure that everyone has the right thing available to do their job and run the applications that organization needs to. Lifecycle management of hardware is quite difficult. It's very time consuming. This negates the need for a lot of that. There is life cycle of the development environments that you use as a developer to write all of this. There's also the life cycling of any licenses associated with that, but that's pretty much it. There's no making sure your hardware is on a 3-year refresh. There's no making sure that you replace failed disks quickly. Any of those things, that they all disappear. Next one's around security. So one of the big drivers a lot of clients that I work with go to things like containers is the inherent level of security that comes within that platform itself, let alone the platform that it sits on. So AWS and Azure are both very secure platforms that you can run your applications and your code on top of. Add to that containers as a technology that adds its own layer of security, and then from a platform level, as well as physical security in the data centers, you also have extremely granular control over who can do what to specific instances. That makes it a very easy sell to your info security team about how you manage access to a lot of these resources. So that's a really important thing to think about. One that is obvious, but I couldn't leave off, is around reliability. So, we need to make sure, and I've just noticed the icon's wrong on there, apologies, but one of the things that's really key is reliability. By making what we are doing so segmented to the specific function we want to perform, we increase reliability. I'll always remember some Gartner research that came out a while ago that said of all the enterprises that they spoke to and all of the 5,000 plus elements of downtime that they looked at, over 90% of them were caused by underlying software or hardware failure. So being able to abstract to that outer level and remove a lot of the periphery and things that can go wrong, it's like a lot of things. The simpler it is, the more reliable it is. The more complicated it is, the more buttons it's got, the more lights it's got, the more underlying infrastructure it has. There are more points of failure, so that is a lot harder to keep it as reliable as possible. Not impossible, but it's harder to do. Next thing as well is lower costs. A lot of people think that when you move to the cloud, you will inherently save money. And that is true, but not when it comes to infrastructure services. It's quite common for clients to spend a little bit more if they move to infrastructure-based services. But when you start to modernize towards cloud-native services, that's when you really start to save money. It's also faster as well. So, we want to make sure that we can deploy things as quickly as possible. This is all about value. One of the key things about DevOps is realizing value as quickly as possible. That's a really key element that these services bring. There's no more standing up infrastructure and waiting weeks for it to happen. It can happen in seconds with fairly minimal effort. Now, a lot of those benefits actually are shared with IT pros as well. So especially around lifecycle management and the ease of management within there, but also integration. So if you could go about integration with other services, microservice-based architecture or domain-driven design architecture, and cloud-native technologies that empower a lot of those things, like serverless functions, like API, applications or containers themselves, lend themselves to ease of integration with other systems. But also as well, one of the key things is because cloud native gives ultimately developers more power, that they can deploy and manage this stuff themselves without ever really needing operations. The companies that spend the time and effort getting DevOps right are the ones that will flourish when it comes to cloud native, because there has to be a close relationship between your operations and your development team in order to make sure that everything goes well and everything runs smoothly. So that's really, really important. So just really quickly, what is some example of legacy architecture? So in this one, we have two applications accessing the same data source. Some of the problems we can see there, that is from security perspective, the auditing is poor. Everyone has access to the full data sets. Encryption is only on the database level. And we also have two servers accessing the same data when they may not need to. Move that to a more cloud native based architecture, and we move to a more API service based architecture where we access our data through APIs. So both of our services are now accessing one API that is managed and controlled by our team, that is developed and updated. And using various different tools that are out there, we can understand what talks to those systems, how often it does it, and what data it accesses. so that we know when we make upgrades what we're affecting and who will be affected by the work that we're doing. It's also fully encrypted end-to-end. The access is a lot more granular. And from a resiliency, security, and an auditing perspective, and some of the things that we talked about earlier, it's just a lot easier to do end-to-end, and it's something that is much easier to manage going forward, and it's something that is more resilient, and security is baked into a lot of what you do by design. So we'll come back to some of the key takeaways at the end as a summary. So just moving on to DevOps specifically. So from experience, DevOps is pretty difficult to get if you're purely an operations engineer. Now, some of the things that I think that boils down to is because cloud native is very developer focused, for one. Secondly, I think because a lot of the practices within DevOps and principles that were born out of DevOps are born into DevOps come out of the software engineering world. A lot of developers have been doing stuff like this for a long, long time, and sometimes not realized it's become DevOps. You can't say that more recently, but certainly in years gone by, it's very common to come across developers who said, oh yeah, we do that. We didn't realize that was DevOps. But as it's become more common, it's pretty obvious. So a lot of the technologies that are used in there as well are also more native to the day-to-day software engineering function, and a lot of the terminology is as well. And I think a lot of it ultimately boils down to the pure difference in roles. So some of the things you quite often hear operations teams say, my developers don't get it. They don't understand that their job is to maintain availability and performance. They think developers throw things over the fence. They go from developing one feature to another really quickly without any handover. There's no documentation, and there's a lot of bugs. Now, those are inherently related, although operations feel the pain of those problems. That comes about because the processes are not right. It means that the teams are not interacting properly. And ultimately, this is how we've come up to have DevOps as a notion that a lot of organizations fall today. From the developers side, right, let's balance the argument out a little bit. So developers, their job is to release features for the business as quickly as possible. There's little engagement from operations until right at the end. The infrastructure needs building. It takes weeks for that to happen. And we never know how the application's performing, so there's never any feedback loop. So, those on the session that are very much into DevOps within their organization will be able to read these lines and say, well, this is continuous integration, this is continuous feedback, this is just the culture you get from DevOps around working closer together. Now, that's absolutely right in a lot of ways. So what does DevOps do? I know a lot of people will know this, so apologies for teaching people to suck eggs, but it's sometimes good just to remember why you are actually doing things. So DevOps is, broadly speaking, a combination of software development and IT operations and bringing them together. What are our primary goals or values? It's around reducing delivery times, improving quality, enhancing productivity, introducing high levels of automation as well, and also putting a strong focus on culture. Whenever I talk about DevOps to any of my clients or anyone within the organization, a lot of people talk about technology first, but actually I think technology is last when it comes to DevOps. I think that if you get the culture right within the organization, that then determines what people you need, what skills those people need. Once that's determined, you will then be able to use those people to determine the right processes that you need to use. And then finally, and I think where a lot of the value comes in, which is why people put so much focus on, is around the technology. And the technology will help automate and standardize those processes that you have put in place. And that is where you will start to deliver a lot more value. Now, you could do DevOps pretty well without any automation if you had correctly designed processes and if everything was in the right place and everyone knew what they were doing. Automation helps us do the same things a lot quicker. It helps us doing it in a more qualitative way. It helps us do them in more predictable ways. That is why automation exists, and that is why automation has a big part in DevOps. So if your organization is thinking about DevOps or trying to implement DevOps and technology is the focus, then make sure that the culture, the people, and the process is in place first. Otherwise, I can almost certainly guarantee that is something that you're going to fail at. So as we've said, right, DevOps is the best of both worlds. So what do you need to be a good DevOps engineer? So first of all, you've got to be a pretty good sysadmin, right? You have to understand the cloud, first and foremost as well. But when we talk about the cloud, you also have to understand fundamentally networking and storage. You are not going to find many organizations in the world that are completely cloud native when it comes to their technology stack. So there is going to be some networking, there is going to be some storage. Also helps if you have knowledge and understanding of coding as well. We're not saying you have to be a programmer, but it helps if you understand what's happening and can read the code and can spot what's happening. Okay, we'll come back to soft skills in a minute because that's actually one of the most important, I think. You also have to have a good understanding of the automation tools that are available and the ones that organization uses, as well as knowledge of testing, right? You have to understand what is happening when a test automation is run, for instance. You have to understand what it means when unit tests fail, when regression tests fail, when SIT testing fails, all of these things fail. And what it means to the overall process and how you go back and fix some of those things and who you need to work with. It's really important to make sure that you understand testing. Security as well. We talk about security a lot in DevOps today, DevSecOps. It's not really anything new. It's just, for me, DevSecOps is around making sure that people fundamentally grasp what needs to happen with security in a DevOps notion. It's around engaging InfoSec in a more detailed and constructive way. It's around making sure that you treat security the same as you would with the release process, automation. It's around making sure that you do security testing much earlier in the process. It's all of these things. So it's actually nothing new. An organization should really have been having good security practices in place for a long time anyway. It's just that they seem to have been diluted somewhat the more we've done DevOps. So hopefully this brings people back. And then, around soft skills, right? Soft skills are a huge part of DevOps, knowing how to properly communicate, knowing how to collaborate, knowing how to behave in the different ceremonies that are involved with Agile, whether you're doing stand-ups, retrospectives, sprint planning, all of those different things. Having the right soft skills to interject at the right time with the right piece of quality information is really important. And for me, this is what separates out a regular infrastructure engineer or infrastructure architect to a DevOps engineer and a DevOps architect. It's someone that understands these sets of things rather than just the top three things on the left-hand side. So where does the IT pro fit in? So from an operations perspective, right? If you're in operations, you have a huge amount of operational knowledge, right? You know lots about the business, how the business uses those applications, and what it means to the business when the application is no longer available. Right? Imagine how much power you could give to the development teams if you apply that knowledge early in the development process. That is all about what DevOps is. Ensuring that your operational requirements are included in the solution phase before it's built rather than afterwards. You can also support the cloud native technologies that have been built as well. If there's any developers on the call, apologies for the next comment, but generally speaking, I won't say this broadly, generally speaking, a lot of the developers that I've worked with before, a lot of them are not great around thinking around things like backups, disaster recovery, and those elements of operations that are really important to make sure that a business continues ticking in the event that something bad's happening. All of those things are well within operations as well, but sometimes the application needs to be designed and developed in a specific way to make that easier or to make that possible. So that's where operations knowledge can come in really, really important when it comes to DevOps. If you're in service management, right, really quickly on this one, ITSM still plays a big role. DevOps gets quite a lot of criticism in the service management world because a lot of people assume and think that it's to circumvent process, when actually it's around making those processes leaner. It's around making sure that when you need to raise requests for changes, RFCs, it's around making sure that people understand that a lot of the things they would manually check have been done automatically in our pipeline. So if you're in service management, you need to understand the automation tasks that take place that replace any previous manual tasks. You need to understand that the toolchain can integrate with your ITSM tools and that we can send whatever information you need and want out of those pipelines that we automate for our build and release into there to be able to get the information you need, right? Last point on here is around eating the DevOps dog food. Right? It's no good one part of the organization doing DevOps. Everyone's got to do it. So use it as an opportunity to look at things like agile service management. Okay, so from a leadership perspective, as we start to come to the end of the session here, so leadership plays a vastly important role when it comes to DevOps. So they may not understand DevOps, but they understand the value that DevOps brings, and it's really important to make sure that that is instilled within your organization's leadership team. So they need to be aware of the business value that DevOps is bringing. They need to embrace the cultural change that enables your organization to ultimately go faster. The things that we do in DevOps have to be pushed down from the top. You, as a leader, talking about the C level, we really need to make sure at this point that you reimagine trust within your organization. What does trust actually mean? You need to design your teams to give them a level of autonomy and empowerment. And you really have to make sure that there's an insatiable focus on continuous improvement. DevOps is all about improving with every iteration. Make sure that you have a nice way to be able to take feedback out of iterations and put it back in at the other side. It's really, really important. Okay, don't measure compliance. Sort of first and foremost is when it comes to measuring, do not measure compliance. You measure and reward the results, not the compliance. Results are not based off adherence to a process. They are based off what comes out the other end. It's really important to make sure that that's catered for. Okay, so bridging your skills gap. So really quickly on this, if this is stuff that you want to be in and you're not, and that's why you're here to learn more, right? Cloud is a must. Scripting and coding knowledge, development tools, development processes, you need to understand all those. But you also need to understand the business, and you need to understand what to automate and when. Sometimes it's just not appropriate for us to automate everything every single time. So it's important to understand when it makes most sense to automate specific processes. Okay, soft skills in communication and collaboration. Again, goes without saying, but to be a good DevOps engineer and to become a better DevOps engineer, you have to have great communication skills, be willing to work with others that don't necessarily understand the tools and the technology that you work with day to day, and be a leader. Right? Leadership is not always about managers and people managers. It's about many other things as well. Anyone can be a leader within an organization without having people management responsibilities. And it is those qualities that shine through and really make people great DevOps engineers over and above what you would normally expect out of a regular sysadmin. And that is where people need to go to be able to further their career. So really quickly, just to finish off, if anyone has any questions immediately, then I'd be happy to answer them, and I'll stay around for a little bit as well. But key things really are the landscape is changing again. Okay, so we've gone through virtualization, we've gone through the motion of moving to cloud. We are now in the midst of the motion of moving away from traditional infrastructure services. Yes, that gives developers power, but don't be scared by that. Think about what happened when virtualization and cloud come in. I spoke to a lot of organizations and engineers that thought they were going to lose their jobs because storage is different and networking is different. And yeah, it is different, but there is still a need for those specialisms and the ability to understand those technologies. So it's all around how you adapt. No one is saying you need to become a developer to have a play when it comes to cloud native, but make sure you understand the technology, because the ability to understand that technology is what is ultimately what will make you a more valuable person to your organization and really give you the ability to, in the future, go forward and really understand this deeply and grow what the team is doing on another side. So those are the things that are really important. So with that, I think I've run over a little bit, so apologies for that. I'll pass it back for any other questions anyone has, and ultimately the next session. So once again, thank you very much.